limit order book is where we keep a record of buyers and the sellers. All of the stock exchanges across the world, pretty much all of them, whether it's stock market, whether it's the foreign exchange market, they are all governed by some type of limit order book. Now, in a limit order book, there are a bunch of buyers and a bunch of sellers. Some sellers are very aggressive. An aggressive seller, right? What does it mean that a seller is very aggressive? If you are so desperate to sell, if you really want to sell, for tax reasons, maybe you need the liquidity, you have to sell. What are you going to do? If you're desperate to sell, most likely you will sell as low as it can be, because if you reduce your price, you will sell. So a seller, you want to sell, you want to sell, I want to sell, and he wants to sell, right? And you are the one who wants to sell at the lowest price. So the price that a person wants to sell at the lowest, because I want to sell, but mine is not as low as yours, not as low as hers. Yours is the lowest price. So we call that the best ask. Best ask, right? Best ask is the price where a seller is willing to sell at the lowest possible price. On the other hand, if you're desperate to buy, you want to buy now. You want to buy now for some reason. For some reason you wish to buy. But a number of other people who also want to buy. So the most aggressive person who wants to buy has to place a higher price. A person who's willing to pay the highest price at that point in time, because this is like a cartoon, right? The limit order book is changing so fast. The buyers and the sellers come and go, and the limit order book moves. It's so rapid. How rapid? In today's financial markets, the trading frequency, 10 years ago, the trading frequency was, people trade, when you say like, what's the highest possible frequency that you can trade? Let's say every 5 minutes. Right now, the trading frequency is microseconds. Microsecond is 1/1,000,000th of a second. By the time I blink my eye, right? By the time I blink my eye and you see that I blink my eye is about 5 to 10 milliseconds, not micro. Micro is faster, right? So if things are being traded at a rate of microseconds, we can't see. We can't see with our eyes, because by the time you see, it's too late. So 60 to 70% of all trading in the current marketplace is at this rate, at the rate of microseconds. And so almost all the trading is done through the computers. Computers meaning that these are not human traders, but these are algorithms. So it's a fight between algorithms. Humans make the algorithms, but it's the fight between the algorithms. Who makes the best algorithm? But because the trading is at a rate of microseconds, in a given day, we can have, 2 million, 3 million, 4 million observations. If we have, in one day, if we have, let's say, millions of observations, you cannot use eViews. You cannot use Excel. It's not going to work. You need to know some more sophisticated scripting languages, right? Not only that you need to know programming languages, but you need to know some scripting languages. So if you want to do your master's, you want to do your PhD, you want to go ahead, and then you graduate from here, you say, I have great computing skills, I know Word and Excel, and no, it's not going to work. Like if you're going to work in the industry, you really need to know some high power processing languages. So on one side we have the best ask. On one side we have the best bid. Best bid is the highest price a buyer is willing to pay at that point in time. The difference between the best ask and the best bid is called a spread. Spread is some sort of a disagreement between the buyers and the sellers. If maybe the transaction cost, if the spread is narrow, if the spread is small, then we say that. So what does it mean that the spread is small? If spread is small means that if you buy and then you turn around and you say, I want to sell now, right? Because if you want to buy, you have to go to the sellers. You have to sell to the sellers. So you have to pay. If you want to buy, you have to go to the sellers. If you wanted to sell, you have to go to the buyers. So if you do a round trip, you buy and sell, right? You will pay the spread. You will pay the spread. So if the spread is large, then the cost of trading is large. If the spread is small, then the cost of trading is small. So that when the spread is small, we say that the market is liquid, right? Liquidity is also another concept that it's a very difficult concept to define because it's not observable. Liquidity is not observable. Some things are observable. Price is observable. We can observe the price. Volatility is not observable. We can measure volatility, but volatility directly not observable. When something is not observable, we say that it's a latent variable. Latent. Not observable, but it's measurable. There are different ways of measuring it. So liquidity is not directly observable, but it's measurable. So if you can buy or sell, meaning that you can trade any amount that you want to trade, whether it's a small amount or a large amount, with minimal price impact, we call it that the market is liquid. So what does it mean? So I'm emphasizing three concepts here in this round. The one concept is the limit order book, the best bid, best ask, best bid, best ask, and the limit order book, and then I move on the concept of liquidity. Because if you go to the market that you want to sell a large amount, right? You want to sell a large amount. What's going to happen? I know that you're so desperate to sell. You want to sell a large amount. What's going to happen? I'll say, you know what? I'll buy from you, but I will pay you very little, right? If I know that you're desperate to sell, let's say you want to sell from 100. You say, I have 10,000 shares to sell, and I want to sell my shares from $100. I'll say, you know what? I'm really interested in what you're selling, but I'm going to pay you 20. And so if you are able to sell your 10,000 shares, you go to the market, you sell them around 100, 199, you sell 100. We call that price impact. That's the price impact. No price impact means that you sell it from the prices that you want. The prices that you want is 100. If you're able to sell, if you're able to sell from the prices that you think it's appropriate, any amount, not 1 or 2 or 5, any amount that you are able to sell from the price that you want, which is the price impact, minimal price impact, then we say that the market is liquid. If the market is not liquid, then you face a risk. You face a risk that you face a price risk. You face a price risk where that you will sell, but you're going to sell it much lower, and then you're going to lose money. So that brings us to the concept of risk, right? I'm sure you have heard about risk. There are different types of risk. Market risk, credit risk, counterparty risk, diversifiable risk, non-diversifiable risk. One type of risk which is non-diversifiable, because some risk is very peculiar, it's idiosyncratic, more like individual type of risk. Individual type of risk, or very specific type of risk, we call it idiosyncratic risk. It's a very idiosyncratic nature, very individualistic, very boutique-y, very special circumstances type of risk. If it's a special circumstance, then it falls under idiosyncratic. If it is if it is a type of risk which is common, then that type of risk is not diversifiable. I cannot get rid of that type of risk easily, right? Non-diversifiable risk. Non-diversifiable risk typically is measured through something called market beta, or sometimes it's called CAPM beta, or capital asset pricing beta. Capital asset pricing beta is a measure of risk which originates from the exposure to general market conditions. It's a type of risk from the general market. So if the market moves up, you're okay. If the market goes down, you go down with the market. You move with the market. You move with the market. If this beta, which we call it the CAPM beta, or the non-diversifiable risk, if beta is 1, then you move with the market. If market is up, your portfolio, you have a portfolio, and if you have a portfolio, the market is large. In the market, maybe there are 400, 500, 600 companies. But your portfolio is a subset of this market. Let's say in your portfolio you have 10 assets. You have constructed, this asset, that asset. Your portfolio is 10 assets, 10 companies. But the market is 600 companies. So if your beta is 1, if the general market goes up, your portfolio of 10 companies also go up. If the market goes down, you also go down. When beta is 1, so beta is a parameter, is a number, is a parameter where if your portfolio has a beta of 1, then you pretty much move with the market. When the market moves, 99% of the time you move up. If the market moves down, you move down with the market. When beta is greater than 1, when market moves up, your portfolio moves even higher. So you make more money on average, because if the market moves up 5%, your portfolio moves maybe 7% or 8%. So when beta is greater than 1, you move in the same direction but higher. When beta is less than 1, you kind of move along with the market, but not as high. You know, if the market moves down, you don't fall as much. If the market moves up, you don't go as much. If beta is 0, then if beta is 0, then there's no correlation, right? Then there's no correlation. So this beta is also called systematic risk. Systematic risk is a calculation or exposure to general market conditions, and the systematic risk is a measure captured by market beta. So let me reiterate. There are different types of risks. Some risks that we can diversify away. We can hold a collection of assets so that when we diversify, we are not exposed to this risk anymore. It is there, but we are holding different things so that we are not exposed to this risk. But when the risk is not diversifiable, I cannot allocate my assets in a way that if I cannot diversify this risk, I am exposed to it. I am exposed to this risk. So the market beta measures the non-diversifiable risk. So if my beta is 1, I move with the market. If my beta is greater than 1, I even move higher than the market. If my beta is less than 1, I move with the market but less, right? So in this paper, this is with a PhD student of mine. So what we are doing is that typically in an economy, there are different types of companies, right? And these companies typically work with each other. Some of them make an intermediate product. This intermediate product is sold to another company. That company, like say if you have an iPhone has a screen, a chip in it. iPhone has so many different components, and these components are made by different companies. And so the companies are connected to each other. Some of them are suppliers, some of them are customers. So there is a linkage. There is a linkage between companies. So the companies do not sit in an economy independently. They kind of produce things. The way that they produce things are hopefully sold to other companies. That company takes that and then produces something else, and then that's sold to another company. But maybe in the country or maybe outside of the country, but the companies live in a network. The companies live in a network. So if the companies live in a network, can we split this market beta? Can we split this market beta, this non-diversifiable risk, into two components, where one component is originating from the customers of a company, and then the other component is originating from the suppliers of a company? It turns out that we can, in fact, split the market beta, or the non-diversifiable risk, into two components. And the argument is this: when there's a financial crisis, everybody wants to sell to you, but nobody wants to buy. In a difficult time, it's so easy to find suppliers, but hard to keep your customers. So in a financial crisis, if you somehow can keep your customers, because there's no problem on the supplier side, they're willing to sell to you. If this guy is not selling to you, you will find someone else to sell to you. If you cannot find a supplier in your country, you will find a supplier somewhere else. They're willing to sell to you. If you want to do something, you want to produce something, you will find suppliers. Sometimes it'll be work. It's not be the type of suppliers that you want, but you will find suppliers. But in a financial crisis, your customers may disappear because they're bankrupt. They don't have money. Somebody took them over. If you can maintain, keep your customers, most likely you will survive that financial crisis. But if you cannot retain your customers, if you cannot sell, then most likely you will not make through the crisis. So in this paper, what we're doing is that we are splitting this risk into two components. The risk is originating from the suppliers. The risk is originating from the customers. And we find that, so this is kind of nice. It's like I'll show you the pages quickly. And what we find is that, and I will give these slides to your professor so you can look at them. And if you have questions, you can ask me later today if you're interested in. I am here today. Sometimes in this type of a short period of time, not to use the slides too much, because so I'm not using the computer as much. But that's the main idea. The main idea is that so what we find is that, in fact, those companies who can keep their customers, they survive. So the risk really originates from the customer side. But to be able to do this type of research, this is you have to know time series econometrics. You have to know cross-sectional econometrics, and then you have to know panel econometrics. Panel is that we have the both dimension. In a panel econometrics, we have a time dimension, we have a cross-sectional dimension. Cross-sectional dimension means that there are companies, there are a number of companies. We look at the behavior of these companies at a given point in time. Now, no time dimension. We have a bunch of different persons, a bunch of different companies, a bunch of different countries. We look at the behavior of these entities at a given point in time. In the case of time series, time dimension, we have a particular entity. This particular entity may be a person, maybe a company, maybe a country. We look at the behavior of this entity over time. But if we have a bunch of companies and we look at the behavior of these companies over time, that becomes a panel. That becomes a panel data or panel model or panel econometrics. So here we have to use both the time dimension as well as the cross-sectional dimension, because I have a number of companies. I have a period which is a crisis period, a non-crisis period, so I have a time dimension. So you have to, I don't know how much you know in econometrics, but before you graduate, it is important. It's not enough to know time series econometrics. You also know the panel econometrics, because for this type of work you have to do that. Now the other part is that when you move into panel type of framework, I have, let's say, in a panel framework, I have so many different companies, or so many different companies. Some of these companies have features, characteristics, like individuals, right? Like with individuals, we see what they wear, how they talk, but we don't know what's going on in their mind. Sometimes we don't know what they're thinking, right? Companies are the same. We have some profit measures, we have some sales measures. There are some observable features of these companies, but also there are non-observable features, like individuals. Individuals have observable features, but also have non-observable features. Both the observable and the non-observable features are important, because, I really like a person. I want to spend time with this person. I want to spend let's say, a long time with this person. But I'm a little bit risk lover. Like, I want to go and climb the mountains. I want to do some crazy excursions. I want to do a lot with this person. But I don't know whether she likes these kind of risks. Like, we are having a great time, but I'm not sure, 5 years down the road, when I say, you know what, let's go all around the world and do these crazy things. So I don't know her level of risk aversion. She doesn't tell me. I just cannot estimate the level of risk aversion. And so this is not observable. Is it important for me? Yeah, it's important for me, because we may get along 5 years, and after 5 years, she says, no, I'm not interested in that. Can we do that? No, I'm not interested in that either. And so that becomes important for me. So if certain features are not observable, it's a problem. We have to measure them. Certain features are observable, certain features are not. Those features which are not observable, we call them, because they differ across entities, it differs across individuals, we call them unobserved heterogeneity. Unobserved heterogeneity. It's a latent variable. It's latent in a sense that it is not observed, but it's measurable. We can construct a proxy. In panel econometrics, this unobserved heterogeneity is measured through two routes. One route is called the fixed effects, and the other one is called the random effects. So there are two main types of panel models: fixed effect models and the random effect models. So as long as you are familiar with main panel models, and these panel models fall into two main areas, the fixed effect and the random effect. These fixed effects and the random effects effectively measure the unobserved heterogeneity. Because in an equation we have the observable features, non-observable features, we put them together to account for. So to do these we have, in this paper, we have to go through this panel framework, take into this fixed and unobserved heterogeneity into account. Yeah, so how much time do I have, Catherine?
40 minutes.
Okay, so let me stop here and before I proceed, any questions? The area which is becoming more important is how to measure, how to take interactions or the relationships into account. I have a relationship with a number of different people, maybe in my Facebook page or Google Plus, or Facebook and Google Plus are different, right? Like in the case of Facebook, if I defriend somebody, then it disappears, right? If I say I don't want to talk to you anymore, so if I defriend, then the relationship is entirely gone. But I think in the case of Google Plus, even if I defriend, the other person still has a link. It still sits in their circle. You can't get rid of that person in their circle. But in the case of Facebook, it's I have no control on their circle. So we live in a network, whether it's a friendship network or customer supplier network or trade network. Countries live in certain type of networks because they have agreements with one another. They have trade agreements and custom union agreements. So things live in a network. If they live in a network, how do we account the relationship between? How do we account this relationship? So that comes through this comes from math, the graph theory. So one way is to account that relationship is, so here's an example where let's say that we have 5 companies. So company 1 sells to company 2 and 3, and 2 also sells to 4. The relationship has a direction. So if we know the order of the relationship, like in this flow chart here, is there any way that we can account this type of relationship through a matrix? Because typically when you look at a chart like this, like you go to Google and you look at the flight networks and friendship networks and all that, it's so big and so complicated, and like there are 10,000, 100,000, you know, it's very, very dense. It looks so crazy complicated. But regardless how complicated it is, this type of interdependence to one another can be accounted by a matrix. The rows of this matrix is from, so the rows are the from, the columns are to, from to. So if you look at the first row, first row is the first person, first unit. Second row is the second company, third. So the rows are the certain companies. So the first one is whether I have a connection from the first company to other companies. So it says that when I look at the first, it says that there is a connection from the first company to the second and the third, because the second and the third has a weight of 1. The weights don't have to be 1. Like you can use other numbers as well. It may be that you can use percentages, you can use sales to capitalization, you can use different types of meaningful measures as a weight. But the simplest way of accounting that would be 0 and 1. So if you look at the fifth row is all 0. Basically says that there is no connection originating from the fifth company to others. So irregardless how complicated, how dense the network is, that network can be accounted by a matrix. And that matrix is called the adjacency matrix. Adjacency matrix summarizes the network. So what is a network? Well, the network is the nature of connections or the nature of dependence between individuals or companies. And the nice thing about this matrix, this adjacency matrix, is that if I take the transpose of this matrix, then the transpose of the matrix tells me the reverse of, so it tells me to from, not from to to, but to from. So it looks at the relationship in a reverse direction. So like if I am a customer, if I'm a supplier, who are my customers? If I take the transpose, then I would do the reverse. So the transpose is very useful. What if I constructed an adjacency matrix and I multiply this G, cap G, by itself, so that this matrix is G to the power 2. If it's G to the power 2, G to the power 2 tells me let's say that I am kind of connected to, like, we're kind of indirect friends. I'm kind of connected to her, but I'm connected to her through you. So how many steps it takes me to reach her, friend of a friend, or I supply to a particular company, whatever that I have supplied to the other company is processed and then sold to another company. So the powers of G tells me the order of the relationship. First order relationship, second order relationship, third order relationship. How deep that I have to go into. This is also quite important because often it's not so much that the risk that I face as a company originates from my relationships, my first order relationships, but the risk may originate from second and third order relationships. Those companies may be so risky that the supplier of my suppliers may be so risky, so that those second order, third order companies may go bankrupt. If they go bankrupt, then it cascades back into my first order relationships, and then I go bankrupt. So often the correlation or the dependence between individuals, or the dependence between countries, or the dependence between the companies is not necessarily first order, but the second order and third order linkages may also be significant in terms of analyzing stability and the risk. So if you look at the higher powers of G, then we account for these higher order linkages. So it's a very simple, very transparent, easy way of accounting a very complicated network in the form of a matrix. I mean, the point is that writing a good paper, if you work really hard, like for me, if I wanted to write a good paper, it takes 9 months. 9 months of solid work. 20, 30 pages of a good piece of work. Like this one is at least a year's work. So it takes a year. And then you have to present it in a different few places before you submit it to a journal. Because if you present in few different places, people give you feedback, you find out whether you made mistakes and so on, and then it's helpful to present. You can't submit a paper, even if you're so confident, it's not a good idea. Maybe you present it to your friends, you present it to your colleagues. That's why in most universities, they have lunch seminars. During these lunch seminars, your friends, your colleagues come and listen and give you feedback, so that if there are some obvious mistakes that you made, you kind of. So once you present a few times, then you submit to a journal, scientific journal. When you submit to a scientific journal, the editor takes the paper. If the editor may not like the paper, it reads it quickly. If the editor doesn't like it, it comes right back. It's not very pleasant, but it may come back, saying that. We call that desk reject. Comes back. But if the editor thinks that what you have done is reasonable, then he sends it to anywhere from 1 to 3 referees. These referees are scholars in different places. It goes to referees. The referees write reports, and that by the time you hear from them, it's at least 6 months. It may take up to 6 months, sometimes more. Sometimes it takes a year. You don't hear. So it goes back to the editor. Editor reads these reports. He writes his own report on it and then sends it to you. He may say, I sent it to 3 well-known scholars, experts. I read these reports, and unfortunately, you don't have good contribution. Sorry. Or the editor, then you have to read these reports. Like if you get rejected, there are 3 reports, you get rejected, you should not send it to another journal like that. You have to revise based on those reports and then send it to another journal. Because if you don't revise and send it like that, it may go to the same referee, and the same referee realize that you didn't revise, and they get even more upset. So you have to revise and send it to another journal. But if the editor says, okay, so I read these reports, this is a good, reasonable contribution subject to revisions. And each report that you get may be 2-3 pages. So you have to work another 6 months, 3 months, maybe 4 months, maybe 6 months to revise the paper based on those comments. So that takes anywhere from 3 to 6 months, and then you send it to them again, to the editor. The editor may send to the same referees. Sometimes he sends it to different referees, and then you again wait anywhere from 3 months to 6 months for the second round. And then it comes back from the second round, and then the editor says, you know what, you really didn't do the revisions carefully. I will reject your paper. So after 2 years of work, 2.5 years of work, back to square one. If the editor says, okay, so you've done a good job, I'll accept your paper, or you will have to do more. So then you go and do those, and it comes back. So by the time that you have started to do the research, and by the time that paper is accepted, not published, accepted, maybe 2 years, maybe 3 years. Like I have just another paper, a paper accepted. First time that we started to work on that paper was 4 years ago. So it takes time. So it's a big investment. It's a big investment to go in a particular direction. And so you have to choose your direction so carefully. So because at the end of the day, you're trying to convince others. You're trying to convince others that what you're doing is important. If you cannot convince others. It may be so important for you, but often it's not important for others. You know, it's just fine, it's okay, it's not like, it's another idea. So you really have to have a perspective to, now, coming back to the question, it has to be something that has not done before, or you have to contribute significantly. Maybe you generalize an idea which was worked on before, but you generalize that idea. And then whatever that you propose have to be robust. It shouldn't be fragile. It works in some special circumstances. That doesn't work. Whatever that you propose have to be robust. That you say, you know, I find these results, but if I disturb or perturb these results into this direction, into that direction, these results are still there. The idea, the results, the theoretical framework should not be fragile, but should be robust. Robustness is so important. Often you fail not because your idea is not good, but because your idea is somewhat fragile. So as long as you control for those factors, then you prevail. So here I'll emphasize the idea of robustness. So what we are doing here is that, as you see, we have a variable on the left-hand side. CR means crisis. PR means prior to crisis. So the difference is the returns of a particular company I after the crisis minus before the crisis. So it's the difference between the two. There is a bar over R because it's an average. It's an average, monthly average. But you can think of that, the return of a particular company I after the crisis period minus the pre-crisis period. And I have an intercept term, and then I have beta C, beta S. Beta C is the customer beta, and beta S is the supplier beta. And then I have a bunch of, like if you look at delta 3, delta 4, up to delta 8, I have a bunch of other variables in the regression. These additional variables are the so-called control variables. Control variables are there for robustness reasons. What I want to find is that in my results, what I want to find is that I want to find beta C to be significant, and I'm not concerned about beta S. Because I think that in a crisis, the risk mostly originates from losing customers. It's hard to retain customers, whereas the supplier risk may not be as important. To make my point that beta C, beta bar C, there's a bar on it because it's an average. To make my point that the beta C is really, really statistically significant, I have to get rid of other types of variables or other type of factors which may also contribute to the difference between the returns and the crisis period minus the pre-crisis period. Sometimes a particular thing happens because there are multiple contributing factors to the same thing. You know, you say, you know what, I really think that this is the reason, and I may disagree. I say that's not the reason. that it's because of that, not because of that. So there may be multiple reasons or multiple factors which lead into same type of effect. So you have to convince the editor, you have to convince the referee, you have to convince the audience that when there are multiple factors, it is this one particular factor which is in fact driving the results. Then you have to control for all the remaining factors. So once I control for those type of factors, this one factor is still important. So that's the difficult thing in empirical modeling. When we do empirical modeling, we have to construct regressions. When we construct regressions, it's not enough to put your variable that you're interested in on the right-hand side and say, look, this is so significant, and the t-statistics are so big, Well, I mean, yes, but it may also be that if you have put some other factor, you would have gotten the same result. So to convince that a particular factor is contributing to a particular result, you have to control. You have to control for the impact of all other factors. Controlling for the impact of all other factors is called robustness. You have to do robustness. I control for this, my result is still there. I control for this, my result is still there. So then you have to think it through and say, I want to understand this type of a problem, but then you have to decide what factors contribute to that problem. You have to know the general factors. What are the most important drivers of which would influence this, and you have to come across very comprehensive and reasonable. Like you have to say, this is really the set of all measurable, all observable set of variables which would lead to this, and I control for all of them. Even when I control for all of them, this particular one is still significant. If you do that, then you're robust. If you don't do that, it doesn't make sense. It doesn't make sense. It doesn't make sense. It's not reliable. It's not important. It's not significant. It just, people don't take you seriously. So if you wanted to come across serious, you're a serious scientist, you're careful, you want to establish that kind of a reputation, you have to do the robustness seriously. Do I have to worry about the error term here? What is the meaning of an error term in a regression? Look, I have a number of variables on my regression plus an error term. Why do I have an error term? What is an error term? Epsilon. The epsilon in the equation. What is epsilon? So I'm trying to explain this. Right? I'm trying to explain this, and so I will split this into two parts. So I'll split this into two parts. The part that I can control, how do I control? Well, I have data. And with the data, there is a part that I can control. I say, maybe I have an intercept here, a mean, maybe I have some beta x. So this is the part that I can control. But after I control as much as I can control, there are still maybe other type of features that either I don't have data, either it's not observable. There is a part that I cannot control. It's outside of my control. So this is the part that I control. As an econometrician, the econometrician controls. This is the part that you control, and this is the part that outside of your control. So all of those factors that outside of your control falls under the error term, right? Falls under the error term. So typically when we write down the error term, we say that the error term it has some distribution. Let's say it's distributed IID, and then the error distribution has zero mean and a given variance. Why is it that we always say that the error distribution here has a zero mean? Why?
Because we consider that we have taken into consideration all the important factors and all the others are not so important.
Well, the reason that, because if this wasn't zero, right? If this wasn't really zero, then if you know that this is not zero, then you should put an intercept term here. You have to put an intercept term. If you put an intercept term is like the average of this, so that once you put an intercept term, this has to be zero. But also, this says, so when this is zero, what does it mean? Guys, this is important. So this part is important. Please listen to me. Especially the ones at the back. If you think that you're going to make a positive error, right? These are epsilon is the things that are outside of your control. The things that you cannot control. If the average of epsilon is zero, then you say these things are outside of my control, but on average, I will make zero error. I will make zero mistake. On average, things which are outside of my control average to zero. There may be things that I'm missing positive. There may be the things that I'm missing on the negative side, but on average, I will make a zero mistake. If you know that on average you will make a positive mistake, put an intercept term. You put an intercept term. If you know that you're going to make a positive mistake, you put an intercept term. So this has to be zero. This has to be zero. If you know that this is not zero, then you put an intercept term, right? And then you put a bunch of, and then you put a bunch of factors, right? You put a bunch of factors. And if you have put all the important factors here, right? All the important factors, then we say that this model is correctly specified. The model is correctly specified. If you have missed some of these things, like if you have missed one of them, where will it go? If you miss one of them, there's no other place to go. Either they have to go here or they have to go here. If you miss it here, then they go to here. But the part that you control and the part that you cannot control kind of have to be orthogonal to each other, right? They should be orthogonal to each other. If you forget and one of these factors fall into this, then that orthogonality is going to be broken and your model is going to be misspecified. The model can be specified correctly, but still this error term doesn't have to be IID. What is IID? IID is identical and independent distribution. IID is also a form of white noise. IID is like the purest, I make mistakes, but the type of mistakes that I make are not forecastable. They don't have any structure. That's what it means. To convince the referee, to convince the editor, to convince the audience, to convince the readers, the model has to be correctly specified. If the model is misspecified, what does it mean that it's misspecified? If it's misspecified, we estimate and make the inference wrong, and everything is garbage. Garbage. You estimate, you get numbers, but everything is garbage. The model has to be correctly specified. If the model is not correctly specified, you say wrong things. Your conclusions are not correct. So for this type of work, the results have to be robust. The model has to be correctly specified. As long as you are careful in terms of specifying your model correctly, and then your results are robust, then you've done good work and things are reasonable.